This ShowMe contains 4 demonstrations of how to apply the quadratic formula to solving quadratic equations in standard form. First, let's solve x squared minus 7 equals 6x. Remember that the quadratic equation is derived from a quadratic equation in standard form. This isn't in standard form. We need to get the 6x out of there and over on the other side. So subtract 6x from both sides, getting x squared minus 6x minus 7 equals 0. Now we're in standard form. A will be the coefficient of x squared. That would be 1. B is the coefficient of x, which would be negative 6. And C is negative 7. Now it's time to make our substitutions into the formula, which is written at the top of the screen in red. X equals the opposite of b. The opposite of negative 6 is positive 6, plus or minus the square root of the square of negative 6, which is 36, minus 4ac, so minus 4 times 1 times negative 7. All that is over 2 times a, which would be 2 times 1, which would just be 2. We should do the calculation inside the radical first. And in there we should do the multiplication first. Negative 4 times 1 is negative 4, times negative 7 is positive 28. So we have 36 plus 28, which is 64. And the square root of 64 is 8. So we have 6 plus or minus 8 all over 2. Well, 6 plus 8 is 14, and 14 divided by 2 is 7. 6 minus 8 is negative 6. Or negative 2. Yeah, that seems better. 6 minus 8 is negative 2. Divided by 2 is negative 1. So our solutions are 7 or negative 1. And put an or between them, and that's your answer. Remember that you have to use the word or you should list them perhaps as a solution set like this. But do not use the word and, because the value of x cannot be both 7 and negative 1 at the same time. The appropriate word is or, appropriate notation is that shown here. Let's try it again, this time with x squared minus 3x minus 10 equals 0. This equation is already in standard form, so we can go ahead and identify our numbers now. A is the coefficient of x squared, which is 1. B is negative 3. And C is negative 10. Making our substitutions then, we have x equals the opposite of b, which would be the opposite of negative 3, which would be positive 3, plus or minus the square root of, under the square root sign, we're going to have the square of negative 3, which is positive 9, minus 4ac, 4 times 1 times negative 10 there. And on the bottom I have 2 times a, which is 2 times 1, which is 2. Evaluate the expression under the radical first. Negative 4 times 1 is negative 4, times negative 10 is positive 40. 9 plus 40 is 49, and the square root of 49 is 7. So we have 3 plus or minus 7 all over 2. Now, 3 plus 7 is 10. 10 divided by 2 is 5. 3 minus 7 is negative 4. Divided by 2 is negative 2. So our answer is 5 or negative 2. Remember again not to use the word and. Do note that these problems where the answer comes out to be integers, those are problems that you could have factored. In many ways, the quadratic formula will seem easy and reliable because you can always go to it. But if you're working by hand, if you don't have a computer program or an application handy, factoring often is faster than this. So don't limit yourself to one method of solving things. Now let's solve x squared minus 5x equals 126. This equation is not in standard form. We need to subtract 126 from both sides. So we have x squared minus 5x minus 126 equals 0. Now we can find our numbers. A will be the coefficient of x squared, which is 1. B will be negative 5, the coefficient of x. And C is the constant, which is negative 126. So for our answer, x equals the opposite of b. B is negative 5. The opposite of negative 5 is positive 5. Plus or minus the square root of the square of b. The square of negative 5 is positive 25. Minus 4ac, so minus 4 times 1 times negative 126. All that over 2 times a. A is 1, so 2 times 1 is 2. Let's begin as we always have by evaluating the expression under the radical. Negative 4 times 1 is negative 4 times negative 126 is positive 504. 25 plus 504 is 529, and the square root of 529 is 23. So we have 5 plus or minus 23 all over 2. 5 plus 23 is 28. 28 divided by 2 is 14. 5 minus 23 is negative 18. Negative 18 divided by 2 is negative 9. So the answer is 14 or negative 9. I'll show you one more here. It'll be a quadratic equation whose solution is not going to produce integers under the radical, and we'll look at how to address that quickly. This time we're going to solve 3x squared plus 5x minus 7 equals 0. This is already in standard form, so we can assign our variable values. A this time will be 3, coefficient of x squared. B is 5. And C, the constant, is negative 7. Substituting our values then, we have x equals the opposite of b, which would be negative 5, plus or minus the square root of b squared, which is 25, plus 4ac. So we have 4 times 3 times negative 7. All of this over 2 times a, which is 2 times 3, which is 6. So under the radical, we have 4 times 3, which is 12, times negative 7, which is negative 84. And negative 84 plus 25 it really does help to copy your symbols down correctly. That plus sign there in the middle is supposed to be a minus sign. That'll make this far easier to work with. I was about to end up with a negative number under the radical, which means there was no solution at all. Let's start over on that calculation. Negative 4 times 3 is negative 12, and negative 12 times negative 7 is positive 84. 25 plus 84 is 109. That does not have a nice neat square root, folks, so we're going to have to leave it under the radical. Still going to have negative 5 plus or minus that, and all of it will be over 6 still. From here then, first of all, this is the only way to, well, one of the two ways to list your exact answers. The other way to do it is to split up the plus and the minus. But in the interest of space, I'll just point out, this is an exact representation of the two solutions. You can't get any more exact than that because 109, the square root of 109 is an irrational number. There's no way to write it exactly in decimal form. However, in most real-world situations, you're going to have to go ahead and get close in order to give a reasonable and meaningful and useful answer. So let's practice approximating that just quickly. So you'll need to know an approximation for the square root of 109 to do this. The square root of 109 is very close, but not exactly 10.44. So, to get one of our approximations, we take negative 5 plus 10.44 and divide that by 6. To get the other one, we take negative 5 minus 10.44 and divide that by 6. For the addition option, the solution is approximately 0.91. For the subtraction option, the solution is approximately negative 2.57. And you should put somewhere, some way that these are approximate, because when substituted in, they will not give exactly 0 on the right-hand side, but they'll be close, very close. So that's the process for applying the quadratic formula. The most important thing to remember every time you want to use this formula is that your equation must be in standard form before you make your variable assignments for A, B, and C and execute the formula. Also good to know that you should always start with the expression inside the radical. It makes the process go much more easily to have that one out of the way from the beginning. Hope that helps set you up for some success.